Right, first, what is a multi-digit? Well, a multi-digit is any number greater than 9. So for example, 10, 11, 53, these are all multi-digit because they have more than one digit, okay? The number 4 is just a single digit because it's just one digit on its own. And we can go all the way from 10 to infinity will all be multi-digit numbers because they're all going to have multiple digits going along the place value chart, okay? So that's very important to understand before we start. The reason that place value is so important to understand before we start is because we're going to use our understanding of place value to partition and break up our multiple digit so that it's back into more manageable chunks that are easier for us to multiply. But before we get into it, let's review what we've done so far in previous videos to understand where we're at now, okay? So our written method started with grid method. Now grid method was really useful because it really showed us what we're doing. We're breaking up those numbers and we're answering them in smaller chunks and then putting that number back at the end to give us our final total. Okay, so that was the start, but it was a bit long. We realised that when we got into bigger numbers, it got a bit long and a little bit laborious. So then we moved into formal written method, which is our columns, okay? But we looked first at expanded method, which was a bit like grid method, but looking at it in the formal written method. So we still partitioned every part, and we still wrote down each individual question and did them in 4 or 5 different rows, okay? Again, a good method for understanding our cognitive understanding and our understanding of what's happening, but it was a bit long. And our method after that still looked at multiple digit multiplied by a single digit, and we did it quicker using a similar method to say addition or subtraction, where we stayed on one row to answer each individual part. So if we were looking at 32 times 5, that first row would have 5 times 32 all in the first row, rather than having a second row for 5 times 2 and then the second row for 5 times 3. Okay? That was another step forward, but now we're at our ultimate step. We're going to add a multi-digit to the second part too, so it's going to be a multi-digit times a multi-digit, okay? It is a leg up, it is our next progression, and there is a little trick to it, something that we need to learn and something that we need to understand, okay? So, let's start. Let's have a look at a green chili challenge. So let's use the example 32 times 25. We're going to start at our smallest value, but it's really important to understand what we're doing. Our first row is actually going to use this unit here times by 32, so it's going to be 5 times 32. And our second row, our last row, is going to be 20, which is what this 2 represents, 20 times 32. And then we're going to add them together. So we're still partitioning it, but we're doing it a little more discreetly. And if we're not exactly sure what we're doing, we might make small mistakes, which is why it's really important at this stage to really understand exactly what we're doing and where our numbers and answers are coming from, rather than just following a process. So let's start together. Let's do 5 times 2. Well, 5 times 2 is 10. So let's put our 10 in as we would do now if we were doing, say, for example, an addition or subtraction question at our shortest method. So I'm going to put my 1 into my tens column as a small little 1, just so I can remember to add it to my tens column when I do that, but I'm going to put my 0 in my units column. Now I can move on to my second part of the question, 5 times 3. Well, 5 times 3 is 15. I've got no hundred, so I can just put the answer straight in there, but I must remember to add on that 1 that I had in my tens column from before. So 15 plus 1 is 16. So the answer to 5 times 32 is 160, okay? So, good, we've done that first row. Now I'm going to do 20 times 32, but I don't want to look at it as a 20, and here's the thing that's going to get tricky, okay? Here's the thing that we need to understand. Here's the difference between this method and our previous method in terms of how hard it is. Okay, so we're going to include what's called a placeholder because we want this whole question to be 10 times smaller to work with. We don't want to work with 20 times 32, we're going to still do 2 times 32. And to make it 2 times 32, we're going to make our answer 10 times larger because we know it's not a 2, it's actually a 20. So let's make our answer 10 times larger by putting a placeholder. I'm sure you've all done this, but you might not be sure why. Okay, so we're putting this placeholder in there because if we do 2 times 32, we need our answer to actually be 10 times larger than that. Okay, so put this placeholder in there. Now I can treat it like 2 times 32 again. 2 times 2 is 4. Put my 4 in the next available column, which is my tens column. And again, this is where some people might make mistakes because they think, well, I've just put my 0 in my units column, but I always meant to put my answer in my units column. Well, that 0 is holding the place of the units, okay, because we're 10 times larger. So our next space is tens. 2 times 2 is 4. And we can check that because 2 times 20 is 40. And that's what it said. Cool, we know we're doing something right. Okay, so the next part says 2 times 3, which is 6. Put that in there, 640. Are we finished? No. Anyone who's done partitioning before knows we've only done the individual elements. Now we're going to put it back together. Again, starting our units, 0 and 0 is 0. 6 add 4 is 10. Remember to move the 1 across. 1 add 6 is 7, plus the 1, 8. 800, okay? 32 times 25 is 800, and that's a green chili challenge. Okay, let's look at an orange chili challenge. Now at this point, I want to highlight something. I want to talk to you about something and an expression we're going to use quite a lot, and that is it harder or is it just longer? Okay, now in this example for the orange chili challenge, I pose to you that it's actually just a little bit longer. This isn't harder, what I'm about to show you, but it's just a little bit longer. And I've given it an orange chili because the only thing we need to understand today really is why this is only longer and not harder. So I've given it orange, although it is actually still probably only a green challenge. Okay, so let's have a look at it. It's 482 times 24. Okay, now let's think back to our understanding of what we're doing. We are breaking this number down into more manageable chunks. So we're going to isolate those two numbers again on the bottom row, and we're going to break it up and we're going to multiply the top row by it in little chunks. Okay, so my 4 is going to times 482 first, which is going to make that first row, and my second row is going to be 20 times 482. Okay, but remember we're going to add that placeholder to make it 10 times larger, so we can just do 2 times 482. Okay, so this is only longer because we've only added a digit to the top line. And we're going to see what happens when we add a digit to the bottom line in a moment. But let's answer this challenge first of all then. So 482 times 24. Start at our smallest value, and we're going to start with the 4 times 2. 4 times 2 is 8. Then we're going to move across. 4 times 8. 4 times 8 is 32. Add 3 across into my hundreds column and 2 into my tens. Good. 4 times 4 is 16. Add the 3, 19. So my answer to 482 times 4 is 1928 and completes that first row. Now my next question is 20 times 482. So we don't like 20, so let's make it 10 times smaller and put it as a 2, but that means we need to make our answer 10 times larger so we actually get the correct answer. So I'm going to put my placeholder in place. Okay, great. Now it's just going to be 2 times 482. So 2 times 2 is 4, add that in. 2 times 8 is 16, put the 1 across, put my 6 in place, good. 2 times 4 is 8, plus the 1, 9. 9,640. Now here's something really important. Look at these extra numbers that we've got in here. These were helping us solve previous parts of the question. And we should have put a line through them when we're finished with them, okay, like I have. And we must remember at this point we do not add it to our total because those numbers have already been used and we've already got them added to whatever we needed them for, okay? So we don't want to add them again now, so let's make sure we don't do that, guys. That's really, really important, a top tip. Okay, and remember, add it together, so put my line across, make sure I add it. 8 add 0 is 8, 2 add 4 is 6, 9 add 6 is 15, move my 1 across, put my 5 in place, and then 1 add 9 is 10, plus the 1 is 11. 11,568, and that is your orange chili challenge done. Okay, final stage, our red chili challenge. Now we are going to make this harder this time because there's an extra element we need to understand, okay? So I'm going to give us the question, 452 times 235. Now these are huge numbers now, so we've got to be really careful and we've got to be really precise. So we're going to carry on like we did before, and we're going to understand that we're going to partition it all, okay? So all we're doing for this first line, for this first row, is we're still multiplying 5 by 452. Okay, so 5 times 2 is 10, good. 5 times 5 is 25, add the 1 is 26. 5 times 4 is 20, add the 2 is 22. So our first row, 5 times 462, is 2,260. Okay, right, now our second row, same as before, we are now looking at this 3, but it's not a 3, it's a 30, so let's make it 10 times larger by putting in our placeholder, okay, because it's a 30. It's 10 times larger than 3, which is what we want to be dealing with, okay? So just like before, 3 times 2 is 6, 3 times 5 is 15, 3 times 4 is 12, plus the 1, 13. So 30 times 462 is 13,560. Okay, great. Now, we've got an extra number. We've got this 2, this 200 here, okay? Now we want to do just like before and multiply it by the top row, so we're going to do 200 times 452, but I need to think about my placeholders because I can't just put one placeholder because that would mean the 2 actually turns to a 20. But it's not a 20, it's a 200. It's in our hundreds column. So I need, that's right, 2 placeholders, okay? Because 200 is 100 times larger than 2, the number we're actually going to be multiplying with, okay? So I need to put 2 placeholders in now. Now we can just carry on like before. 2 times 2 is 4, making sure I put it in the correct column because I've now got 2 placeholders occupying the units and the tens column, so I'm going to put this straight into the hundreds column. So 2 times 2 is 4, and I can check that because 200 times 2 is 400. Okay, great. 2 times 5 is 10, so we put our 1 across and put our 0 in the right place. And 2 times 4 is 8, add the 1 is 9. Okay, great, we've just done our third row. Okay, let's make sure we add it up. So 0 plus 0 plus 0 is 0, obviously. 6 plus 6 is 12, making sure not to include that other 1. 2 plus 5 plus 4 plus that 1 is another 12. And then 2 plus 3, add the spare 1 is 6. 1 plus 9 is 10. So we get 106,220. Now, anything beyond this level is just going to be longer. Now we can have a 4-digit number multiplied by a 4-digit number, and all that's going to do is add another row where we need to add 3 placeholders because we're looking at thousands now. We could look at 1,000,000 times 1,000,000 if we wanted to, okay? It's not going to make it any harder, it's just going to make it longer. But don't forget, sometimes when we do things longer, we might make mistakes. So it's really important that we check our work and are really, really careful, okay guys? Well done. So let's recap some really important things from today, guys. First of all, it's really important to put our layout and our numbers in the correct columns. This is really, really important today because we've got such a huge amount of numbers that we're going to be multiplying. And when you get into 4-digit numbers and 5-digit numbers and anything like that, you actually get a really big area where your answer is, and it comes out in like a triangle formation as the number gets bigger and bigger. So if you're not in the right columns, it can look really messy and almost be impossible to make sure at the end when you're trying to add up, you're adding up the correct columns. So organisation and layout is really important. The second thing to understand is knowledge of partitioning and knowledge of place value. Understanding that when we're timesing 32 by 25, we can break it down into those smaller chunks and understand what chunks we are actually multiplying at the time. Okay? Next thing to remember is our placeholders. Placeholders are hugely important to understand, not just to do, but to understand. Okay? We need to understand what we're doing. If we're doing 25 times 32, and we've got the 32 on the top and 25 underneath, then we need to understand that when we come over to that 2 part and we're timesing the 2 by 32, then it's not a 2, it's a 20. Okay, we're only wanting it to be a 2 because 2 is easier to multiply. Okay, so if we are making it a 2, we've actually made it 10 times smaller. Okay, so when we make our answer, we need our answer to actually be 10 times larger, what it's supposed to be. Okay, so placeholders are really important to understand. And the final thing, final recap, make sure that when we've done our answer, we don't just finish with the partitioned answer, we actually add it together to give us our grand total, because that's what we're looking for. We're not looking for the partition numbers, we're looking for that grand total. Okay, well done. Right, I'm going to put some questions for you on the board here, guys. I'm going to put 4 questions. There's a green, an orange, and a red. So challenge yourself. So, what do we need to know already? This is our prior learning. We need to know this before we can get into this video so that we have a good understanding of these things before we are adding in the fraction element, okay? So, hopefully we understand that the area of a shape can be defined as the surface that that 2D shape takes on any given surface. So, for example, a good way of thinking about it is if we were looking at a football pitch, the perimeter is the white line that we can measure all the way around, and the area is how much grass we are going to need. The grass is over the surface, it's the surface area, okay? And we measure area by cutting it up into squares, so we cut the length and we cut the width into squares, therefore our measurement is recorded in squares, meter squared, centimeter squared, any kind of measurement, but we are measuring it and recording it with squared. Okay, and that's very, very important to remember. So let's have a go at a question. Let's have a go at a rectangle with sides of 4.5 meters and a width of 1 meter and 5/6. Okay, well what does that mean? Let's try and break it down a little bit. So looking at the top length of 4 meters and a half a meter, that means we're going to be cutting our rectangle into 4 equal meter width columns going across. And then the last column is only going to be half a meter. okay? And therefore the width of 1 meter and 5/6 of a meter would be split into one row of 1 meter, and the last row, that is a measurement of 5/6 of a meter, not quite a meter. So the 1/2 on the end, that's a fraction, and the 5/6, that's another fraction. When we overlay them, we can see our squares. And what we're needing to do is we're going to be measuring how many squares we have. Okay, so let's start. Okay, so where to begin? Well, we know that the area of a rectangle is length times width. But before we can do that, we're going to convert our mixed numbers into improper fractions. Why do we do that? Well, we can't multiply a fraction and a whole by a fraction and a whole. Okay, so we need to convert it into improper fractions so that we are just dealing with the fractions and we are multiplying those. Okay, so let's have a look. So how do we get from our 1 and 5/6 back into our mixed number? Well, it's pretty simple. Our unit of measurement is sixth in this example. We're looking at 1 and 5/6. So everything is measured from the sixth. So I have one whole. So let's make a bar of chocolate, split it into 6. I've got one whole of them. But in my next chocolate bar, I don't have a whole, I only have 5/6. Okay? So I've got one whole, which is 6/6, and 5/6 in the next one. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 what? Well, they've always been measured in sixths, so we're going to move it back into sixths. Okay, 11 sixths. So for my next one, 4 and 1/2, again, everything is measured in halves. So I've got 4 whole chocolate bars, which were measured in half. So I've got 1, 2, 3, 4 whole chocolate bars, and I've got half a chocolate bar. So in total, how many halves have I got? 1, 2, 3, 4, 5, 6, 7, 8, and then the ninth, 9 halves, okay? Okay, so my new improper fractions look like 11 sixths times 9 halves, or 9 twos, okay? And that is the hardest part. If you can get a good understanding of moving from a mixed number back into the improper fraction, you are halfway there, okay? Now, just like in any times when we're looking at fractions, we want to try and simplify them as much as possible so that we can see them as clearly as possible. So I've got 11 sixths and 9 halves. Now, before we go ahead and multiply these numbers, we're going to try and simplify them. And I've noticed that we've got a 6 on the bottom row here and a 9 on the top row here. And since 6 and 9 can both evenly be divided by 3, we're going to go ahead and simplify it a little bit, okay? So 9 divided by 3 is 3, so I can change that on that top row to a 3. But whatever I do to the top row, I must do it to the bottom row. So 6 divided by 3 is 2. Now sometimes you won't be able to simplify the question, but if you can, it's always worth doing because it makes our numbers a lot smaller and a lot more manageable to see and to use, okay? So my final set of improper fractions and the ones we're going to multiply are 11 over 2 times 3 over 2. And all we do when we're multiplying fractions is we multiply the top row and then we multiply the second row. So I'm going to go ahead and put 11 times 3 over 2 times 2. Now 11 times 3 is 33 and 2 times 2 is 4. So my answer as an improper fraction is 33 over 4, okay? But because our question was given to us in a mixed number, we're going to convert it back to a mixed number, okay? Now we can simply divide this if we have a good understanding of switching between improper and mixed number fractions. So we could do 33 divided by 4 gives us 8, remainder 1. But if we need to understand that a little bit clearer, let's think about it back in our chocolate bars. So I've got 33 quarters. So I'm going to create some chocolate bars and split them into quarters and wait till I get 33 of them. So I've got 1 chocolate bar, 2, 3, 4, 5, 6, 7 and 8 chocolate bars takes me to 32. So I'm going to have a 9th chocolate bar with 1 quarter coloured in, okay? So again, I've got 8 whole and 1 left over. Now our whole fraction was in quarters, so what do we have left? We have 1 quarter. Each of these chocolate bars and each of these segments was worth a quarter. Well, 8 whole and 1 quarter. But what have I forgotten? That's right, always remember to put your measurement in. Meters squared. 8 and 1 quarter meters squared. And that's our final answer. Well done, guys. Okay, now I've got a bit of a fun investigation for us today. It's a multiplication activity. Now, I have got a target number, and the target number is 7,144, okay? Your target, your objective, is to hit my number with your answer, okay? But there is a rule. You are only allowed to use two digit numbers to multiply together to try and hit my target. Okay, so for example, I use a very basic one. If I did 10 times 10, I would get 100. Okay, now I know that's miles away from the answer that I'm looking for, but that's just an example. But that's interesting because this is what I'm wanting you to explore. At this point, when we get an answer, so for example, I've got a very bad answer, I got 100, I'm going to evaluate my result that I got and then analyse my question so that I get something a lot closer next time, okay? There's no point just doing random questions in order to try and get to my target. We're going to look at the answer I got in my previous one and adjust my next one accordingly, okay? So for example, I got 100, that's so far away that I'm now going to choose 99 times 99 for my next one, okay? They're the sort of two ultimate ends that I could do, okay? So, you have only 6 chances to try and get as close to my target as possible. If you hit it, go ding, you get yourself a prize. No, you don't, but you could do. Bit of pride, okay? But you only have 6 chances, okay? Now, when you've done that, then you get to do something yourself. You get to create your own 5-digit number. So it could be anything. It could be 1, 2, 3, 4, 5, 12,345, okay? Could be that, could be anything you want, okay? And then you get to set your own rules for the investigation. Do you want it to just be a 2-digit number multiplied by a 2-digit number? Do you want it to be a 3-digit number multiplied by a 2-digit number? What do you want it to be? That's your objective. And then, again, you only get 6 chances to try and hit it. But you can use a combination of people around you. If you want to ask your parents or ask your brothers or sisters to have a go, use up one of your lives, you can. That's the idea. Get a bit of fun in there, okay? So I'll go through it again. The first part, you have got to hit my target number of 7,144 using 2 2-digit numbers, okay? The trick is going to be your first one. You want to try and get as close to it as possible, your first one, in order to hone in to get to the right answer, okay? So think really carefully about your first question that you write. After that, then you're going to produce your own 5-digit number and ask people around you to help you try and hit it, okay? With either a 3-digit number multiplied by a 2-digit number, whatever constraints of the investigation you want to have. Now I'm going to go through one example of what a 2-digit number multiplied by a 2-digit number looks like so that we don't get any mistakes in that, because that would be fatal, okay? Okay, so let's have a look at one together. Let's have a look at 25 multiplied by 32. Now it's really important that we lay this out in the correct columns, so I like to put our titles of our columns in place. So we've got units and tens here, okay? So 25, 2 tens, 5 units, 32, 3 tens, 2 units. I've got it all laid out perfectly. Good. Now, what are we doing first? Well, we're going to multiply the 25 on the top row, and I'm going to partition my bottom row, okay? So I'm going to have 2 lines of answer here, partitioned, and I'm going to add them together at the end, okay? So my first line is going to be 25 times 2, and my second line is going to be 25 times 30, okay? So that's really important to understand what we're doing at the time. Let's do the first line together, 25 times 2. Now, I don't even like doing that. Let's break it down even further. Let's multiply our units first of all. 2 times 5 is 10, so I'm going to write it as if I would write it in any other column method. Put my 1 into my tens column, ready for the tens answer, and put my 0 in the units. Now let's multiply our unit by a 10. 2 times 2 is 4, put the 1 back is 5. 50, okay? And we can check that because we know 2 times 25 is 50. We could have just done that, but it's good to go through the right method. Now let's do our next row. We're going to be multiplying 25 times 30, okay? But again, let's break it down even further and do it nice and simply. Now it is a 30 there, but we don't want to multiply by 30. Let's multiply by 3 by making our answer 10 times larger by putting that placeholder in place, okay? So I'm putting my placeholder there so that I can look at that 3 as just a 3 and not the 30 that it is, okay? So now 3 times 5 is 15. Put that in place. 1 goes into that hundreds column now. 5 in the tens column, fantastic. 3 times 2 is 6. Add the 1 that's already in the hundreds column is a 7. Now I've got my answer. Am I finished? No, I need to add it together because I've partitioned it, I've broken it apart to do it. Now I've got to put it back together to get my final answer. So let's look in the units column. 0, 0 equals 0, obviously. In the tens column, 5 add 5 is 10. Put the 10 across into the hundreds column and the 0 in there. Then add the hundreds column, 7 plus the 1 we've just added, 8. The answer is 800. Okay, nice and simple. So your challenge is to use this method to get as close to my target number as possible. Have loads of fun with it, explore, be creative, analyse your results really well, and good luck. Check out the link below for a description of what to do if you couldn't quite follow these instructions. There is an example on there as well. Good luck, enjoy it, try and be as neat and organised as possible. Enjoy.